Hi, hello everyone. My name is Assaf Tzur-El, and I'd like to give you a taste of my workshop titled How C++ Actually Works, where I show how actually C++ works under the hood, hands-on compilation, memory, runtime, all that stuff. I wasn't sure that I was going to be able to attend at this time. This is why I recorded this yesterday. So we'll start the recording, and after that, I'll be available on the town and on the Discord channel for this preview. Okay, and I'll see you there. Hi, my name is Assaf Tzur-El, and you're here for a preview of my C++ online workshop, How C++ Actually Works, where we see how C++ works, under the hood, compilation, memory, runtime, and all is going to be hands-on with live coding that I'll do here, and you can and should experience for yourself. As I said, my name is Assaf. I'm a software developer, architect, tech lead. I've been in the business for 3 decades now, and I've been teaching C++ for 16 years now. Wow. Yep. And my background is real-world production systems, not theory. I'm not a compiler engineering, okay, like real-world stuff. But I have this need, maybe an obsession, okay, to know how things really work, understand exactly what's happening when I write code, when I'm using tools, when the runtime is running, what's going on, behind the scenes and under the hood. And this workshop and this preview shares what I've learned from investigating how C++ really works. And I'll show you how you too can investigate these things yourself using real tools. Because your C++ compiler is doing things behind your back. Some of them are helpful, some are surprising, and all of them are very important. And in the next hour or so, I'll show you 4 things that will make you a better developer, a better debugger, and will give you a new power with tools that you already have and you're already using, your own IDE. What we're going to do here, so we'll use real, simple, common tools that you already have, as I promised. No theory lectures, okay? We'll actually look at memory, assembly, compiler, output, like hardcore. And this is going to be hands-on investigation, seeing what actually happens. Now, what you're going to expect from today, as I said, we'll explore 4 topics today. And each one will give you practical insights that you can use tomorrow morning at work. And at the end, I'll share with you what else the full workshop covers. And these 4 topics are just the beginning, just the tip of the iceberg. So, you know what? Let's start. And we'll start with the humble int. So let me share my screen. And yep, this is, a simple program. We're not going to write clean code, okay? We're going to write minimal code to show some examples. And this is an int, I. And let's assign it some kind of value. Now, what happens here between the moment I start it, I create it, and the moment I assign something to it? What's the value of I? And of course, the right answer is garbage, which actually is whatever happened to be in these bytes of memory that now I occupies. Okay, so it's going to be random stuff. Let's try that. So I'll put a breakpoint here, and I'll run this. And let's see what I contains. And sure enough, this is some random number. Or is it? Wait, do you see the pattern? Is it only me? Okay, if you don't see the pattern, maybe I can show you. Let's watch it in hexadecimal. Okay. Okay, what's going on here? Well, it turns out that the compiler is trying to help us. When compiler will fill uninitialized values, will actually initialize it with hexadecimal value of CCCCC, as you can see here. This is the Visual Studio compiler and debugger, by the way. Okay, other systems might have other values, and the idea is to help you catch uninitialized variable bugs. Okay, so if you see a value with CCCC, then you'll know that this is uninitialized, or maybe you assigned something from an uninitialized variable. And if you see CCCCC and then a D, it means that you started with an uninitialized value and then plussed it, right? Added 1. So this is actually very, very smart and very helpful. And this is done in debug mode, because in debug mode, we're not concerned with performance. So initialization is okay. And on the other hand, we are concerned with debugging. So we need to know what the source of various problems are. For example, now I know that in certain cases, I can track the problem, trace it to an uninitialized variable. Okay. And as I said, other compilers have different values. And even the Visual Studio compiler that I'm using right now has different values for different kinds of variables. For example, if I try this with a heap, then I'll see another type of another pattern, CD, CD, CD in this case. And we'll talk about that, all these patterns in the full workshop. Okay, so we'll see in the full workshop, we'll see more patterns like the CC. We'll understand when each one appears. We'll talk about what other compilers and platforms do. And we'll even talk about what food has to do with that, specifically bad food and dead beef. And yeah, there is actually a meaning to all of this. Okay. And with that, let's expand, because integers are a pretty small thing. So let's expand. Let's talk about a collection of variables, a struct or a class. So let's assume for now that the size of an int is 4 bytes. In the workshop, we'll show that this is not always the case. But for now, let's assume that, all right? So let's see the size of a struct. So I'll have this struct, and I'll call it, I don't know, my struct. And it's going to have a single int inside it. And I'll do something like, oh, I'm still running. Okay. And I'll do something like this. Size, or let's do it properly. Size, and it's going to be size of my struct. Oops. Okay. Breakpoint here. And we can see that the size is 4 bytes. Yeah, let's turn off the hexadecimal. Okay, so the size is 4 bytes. So a struct doesn't have any overhead over an int. That's nice. Good to know. Let's say that I have another one, J. Okay. And as you probably expect, the size is 8 bytes because 4 plus 4 equals 8. Okay. Now I'm adding a character, C. So 8 plus 8 plus 1, 4 plus 4 plus 1 equals 12. What? That's not good, right? I mean, what's the size of a character? Come on. Can't be, right? Okay, so a character is 1, but 4 plus 4 plus 1 equals 12. You want to see it even weirder? Okay, how much is 4 plus 4 plus 1 plus 1? Place your bets, ladies and gentlemen, because the answer is, okay, 4 plus 4 plus 1 is, sorry, that's the size of a character still. That's what happens when you do live coding. Yep. Now you know that I'm doing it live. Okay. And 4 plus 4 plus 1 plus 1 equals still 12. Wait, it was 12 without the character. Now it's 12 with a character. Now what happens if I just change things? The size is now 16. What's going on? Well, some of you are probably mumbling or maybe even shouting at the screen, alignment or padding or both. And you're absolutely right. Okay. The CPU likes or wants data to be aligned to specific boundaries. Okay. So in this case, we'll have multiplications of 4. So the size of a struct would be either 4 or 8 or 12 or etc. etc. But why the 16? What's going on with this thing? So I won't tell you everything right now because we have to keep something for the workshop, but we already know that struct sizes are not exactly the sum of the members inside. And reordering of struct members, okay, matters. So these are 2 takeaways that we can already have right now. And in the full workshop, we'll talk about exact alignment rules and calculations, and we'll see how to change these alignments in our compiler settings. And we'll talk about cache line considerations for performance and arrays of structs versus struct of arrays. We'll talk even maybe about network protocols that are related to that. Okay, so lots of things to say about sizes and about structs. And now let's do something completely different and talk about virtual. But we'll still start with sizes. So I'll keep my struct here. I don't need all that. And we already established that the size of this struct is 4 bytes, right? What's the size of, this is a method, okay? What's the size of the struct right now? Again, I'm still running. Let's stop that. Start over again. And the size of an int plus a method is still 4 bytes because methods don't count towards the size. Methods are related to each instance of the struct, but they're not part of the object itself. Okay, that's good to know. Okay. But what happens now? I'm going to use the magic word, virtual. Okay. It's like hocus pocus of the C++ world. And I said hocus pocus virtual, and the size is now 8. Thank you. Thank you very much. Okay, that was a nice trick, right? And I have nothing in my sleeves. Actually, I have very short sleeves, so it didn't come from my sleeves. Where did these 4 extra bytes come from? So let's take a look at the struct. So for that, we'll need to actually create a struct. For example, my struct, thank you, and we'll call it ms, and that'll be enough. I can examine it already. What do we have here? Okay, so let's take a look at the variable, come on, ms. Okay, and I have this, and you know that this is uninitialized. Yes, initialized. Now you know. Good to know. Okay, so I have I. It's a member of ms, but ms has another member. It's underscore VFPTR. That's a virtual function pointer. You know what this is? And if you said a V table, then yes, you were right, because this is actually the virtual table of the struct. Actually, it's not the virtual table, it's a pointer to the virtual table, and a pointer, and we're running a 32-bit compiler, so the pointer is 4 bytes, so this is actually pointing at the virtual table. Let's see that. Okay, this is the VFPTR, and it's pointing at a table, and this is the first item, the 0th item of the table, and it has all these things that I still don't understand, but I'm sure we're going to learn about it in the full workshop. So we have this VFPTR. It points to the virtual table, the V table, and it's the size of a pointer. So now everything that contains at least one virtual method, including a virtual destructor, becomes 4 bytes larger. Okay? That's nice. It's good to know. So now we know that virtual functions cost 1 pointer per object, and we'll see in the full workshop that they also cost us in runtime another 1 or 2 indirections. We'll also see that we'll see the exact vtable structure. We'll see the layout, all these strange exclamation marks and all these things. We'll talk about how inheritance affects vtables. We'll talk about multiple inheritance and what a headache it causes in the vtable. And we'll see when and how the VPTR is set, because it might change value. It might point at one vtable at a certain point in the lifetime of my object, and then point at totally different vtable in the next moment. And we'll talk about that as well. Okay, so 3 topics, 1 to go. Okay, and let's talk about functions. Okay, because we talked about simple types like integers. We talked about complex types like structs. Let's move to the moving parts, functions. All right. And I'll start actually with C. And where is my source file? So I'll just change the extension of my source file to C instead of CPP. And this is not going to work anymore, but I don't care. Okay. And let's say I have this function, int A and int B, and we're gonna add them. How does the compiler and the linker and everyone involved in this game, how do they see this function? Well, the best way to see it is to cause it not to work and see what they're complaining about. So let's just call this add 1 and 2, okay? And let's see what's going to happen. Okay, so I'll try to run it. And yeah, I don't have it, right? So I'm having a problem here, and this is my problem. I'll show the error here. Okay, I'm getting a linker error, and I know that because the error starts with LNK. Okay, so it's a linker error, and it says that I have an unresolved external symbol underscore add. Reference in function underscore main. So apparently, my compiler and linker think about functions with an underscore prefixed. Why? Different stories. Some compilers use that underscore, some don't. Okay, so I see that the linker expects a function named underscore add. Okay, here, and it doesn't find it, and it's telling me main is calling add, and I can't find add, and of course it can't because I only have a declaration. I never had a definition. Okay, so this is C. Enough C for now, right? Let's switch back to CPP and do the same thing. And of course, I'm going to fail again. But this time I have a different kind of failure. Okay, it's the same error. I get the same error, unresolved external symbol, but says the full name of function. It's an add that takes 2 integers and returns an int, and it even adds this cdecl thing, which I'm going to ignore for now. Okay, but it says it's not just add, it's add that takes 2 ints and returns an int. And by the way, the real name of this is question mark add at yes or something, and we're still referencing it from main. So why is that? Let's make it even harder. Okay, I'll add another one because I can in C++ do this, A and double B. And in order to make it not work, I'll call this one and that one. Okay, so now I'm actually calling the add of the ints and calling the add of the doubles. And of course, none of them exist. So I'm expecting two linker errors. Let's see what they're going to be. Okay, first linker error is the add that deals with integers, and it's still underscore question mark add yes. And now I also have missing the add that deals with doubles, and now it's add yans or something like that. Okay, can you guess what this is and why we don't have the simple underscore add is missing? And of course, the answer is overloading. In C, there can be only one function named add. So when it's missing, we're missing add. Okay, and we're declaring when we're using, when the compiler and linker negotiate things, it's always add without underscore. Again, we're not going to deal with that right now. But in C++, we need to think about overloading. Okay, so when we have an error, we'll say we have a problem with the add of the ints or the add of the doubles. And in order to keep things short, when the compiler is generating things and when the linker is expecting things, they're going to use this. And this, as you might have already guessed, gives us both the name of the function and information regarding the parameters. And as you can probably guess, H somehow is related to integers and N is somehow related to doubles. Okay, so the number of parameters, the type of each parameter is encoded into this thing called a mangled name. Okay, so I think this is very interesting. And this will probably help you resolve linker problems in the future, starting tomorrow morning, as I said. Okay. One more thing I want to show you here. Let's not do this. So I'm here in C++, okay, and I want to be able to reference a C function. So I say extern C. Do you know this? What does this thing do? Can you guess? Okay, let's see. And yep, we're back here. When we do this, the extern C, we're telling the compiler and the linker to refer to this function as a C function. So it won't talk about the add that takes integers and all that, and won't give it the has mangled name. It will just use add because now we're back in C mode, in C thinking. Okay, so now you know what extern C actually means. So it's for compatibility. Okay, that's a nice example. What are we gonna do in the full workshop? We're gonna see this, and we'll talk about more things like class methods and their mangled names, and that include class names, things like that. Uh, 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 we'll talk about namespaces and how they are mangled into, are overloaded by design, right? Because the T is both integer and double and mystruct star and reference and const reference and everything. So how do you mangle that? And we'll talk about how Visual Studio mangles name versus how GCC or Clang, because each one has a different mangling schemes, as we saw in the H and the N and all the decisions, how to encode stuff into the mangled name. Okay, so we'll see all that in the full workshop. So stay tuned. All right, so what did we do today? We explored 4 hopefully surprising discoveries today. We started with debug memory painting, recognizing the CCC patterns and mentioning that there are other patterns. We talked about struct size. We talked about alignment. We saw how just positioning members inside a struct or a class changes the size, the overall size of the struct. We talked about virtual functions. We saw how they're actually seen in each object. We talked about vtables. We talked about the vptr and how it might change during the object's lifetime. And then we saw name mangling. We saw how the compiler encodes type, number, and information, type information, and parameter number, actually. And so 4 insights that I hope gave you practical information that you can start using starting tomorrow morning. So now let's talk about the full workshop. So the full workshop goes both wider and deeper than what we saw today. We'll have, currently I have 15 or 16 topics and counting, because I have so many that I want to show. And that's going to be much more than these 4 that we saw now. And we'll probably even have an option to vote on it, and you'll decide which ones we're gonna talk about. And we'll explore multiple angles of each topic. So when we'll talk about an int, we'll start with the size of an int, which is not trivial at all, and how the bits are organized and how the bytes are organized. Yes, we'll talk about Indianness. And as I said, we'll talk about the CC and CD and other patterns and other compilers and platforms. So there's much more to talk about, even when we're talking about the humble int. So multiple angles, okay? And you know what? I'll tell you about some of the topics that I currently want to talk about. We'll talk about function call mechanics, stack operations, calling conventions. We'll talk about what this is and where does it come from? How is it stored? How does a method know which object it's operating on? We'll talk about the complete build pipeline, pre-processing, compilation, linking. We had a glimpse of that right now when we talked about the mangled names. We'll talk about templates and code generation. We'll talk about move semantics under the hood. We'll talk about RVO, that's return value optimization. We'll talk about copy elision. We'll talk about memory segments. Yeah, we'll talk about the stack. We'll talk about the heap. Both of them, by the way, do not exist, and I'm going to prove it. They're just figments of your imagination. No stack, no heap, nothing. So we'll talk about the non-existing stack and heap, and data segment and BSS and code and whatnot. Since we're dealing with C++, but you see, I'm not afraid to talk about C, so we'll talk about references and pointers and how they're implemented. Speaking of pointers, about smart pointers and Lambda implementations and oh wait, we're running out of time, so I'll stop here. Let's talk about the format. of the workshop. Reminder, it's going to be Monday, May 18th, and Tuesday, May 19th, 4 to 8 p.m. UTC, just according to your local time zone. And please note that you might already be in daylight saving time because summer is coming. So this is going to be 2 days, 4 hours each day. We will probably have breaks and stuff like that. But other than that, it's going to be full 4 hours. It's going to be online via Zoom, no YouTube in this case. We're going to have, as promised, live hands-on exercises throughout, okay? And it's going to be live, so I want it to be interactive, okay? Live discussion, questions via chat on Discord or in person. You can actually turn on your microphone and ask me. I love interaction. I'll share materials via Google Drive during the workshop, and very important, it's not going to be recorded. Okay, so prepare to take notes. Bring a pencil and a paper, or Word editing, some kind of editor, Notepad++ or Word or Google Docs or whatever. I need to talk about the prerequisites, so I'll cover that quickly. Okay, recommended Visual Studio 2022 or 2026. You have the free community edition that goes on Windows. That's the preferred way because, as you saw, I'm using Visual Studio, and you'll be able to follow along like the easiest way. But if you don't, it's no big deal. Any environment with C++ 14 and above, editor, debugger, assembly viewer, memory inspection, and you're good to go. We'll do things that I did here, plus. Okay, so make sure before the workshop that you have this environment that you can actually view memory and see linker errors and stuff like that. Okay, so come prepared with your development environment installed and tested. We won't have time for troubleshooting during the workshop, so everything has to be prepared in advance. Okay, so final words. This teaser just scratched the surface. As I said, it's just the tip of the iceberg. The full workshop is going to be much deeper and wider. It's for anyone who wants to continue this journey with me. Same hands-on approach, deeper, wider, okay? And as promised, you'll walk away with both deep understanding and the investigation skills that you saw today. Don't forget to register at cpponline.uk. Thank you very much, and I'll see you in the workshop.